Welcome, welcome to Correct Science. Today we are going to talk about an amazing math topic on variations. Life, everything changes. There are usually reasons for those changes. So today we are going to talk about those. So let's look at what we accomplished in this video. So this video is the first part of the subsequent videos to come. To talk about variations themselves, direct variation, and inverse variation. Inverse variation. Without wasting my time, let's get going. Okay, what are variations? It says something varies, means it changes, right? Yes, so in mathematics, a variation is concerned with ways and means by which one variable relates or depends on another. So when I am changing this way, I'm changing because of a certain factor, and that's what we are looking at. This includes direct variation, inverse variation, joint variation, and partial variation. We'll be discussing two of these variations in this video. In the subsequent videos, we'll talk about the other two. So let's get going. Okay. Direct variation. What comes to your mind when you hear the word direct? Straight to the point. So they affect each other directly. So it is a kind of relation that exists between two quantities in which an increase in one quantity causes an increase in the other quantity and vice versa. So let's say one pen costs 0.5 cedis or any other currency. 4 pence will cost 2 cedis, right? Yes. So realize that the increase in the number of pens has caused an increase in the cost. At first, the number of pens was 1. When it was increased to 4, the price also increased to 2. We can say this is a direct variation. So the number of pens and the cost are directly related. So phrases like varies directly as is directly proportional to all point to direct variation. So anytime you see them in questions, they are pointing to direct variation. Now, what mathematical expression can we use for direct variation? So for maths, we'll be using this sign, the proportionality sign, to show that it depends on something. So for something to change, it depends on something. There's a factor. Let's say you plan to go out a certain day, but it was raining. So that rain has now become a factor that has changed your mind. You couldn't go out that day. So let's say you have two things. Here, the cost directly proportional to the number of pence. So this is the simple relationship. Okay. Now let's look at uh, the diagram that shows the graphical representation. Here we have y being directly proportional to x. You realize that the increase in x, here let's see x is 0, here it is 1, here it is 2, here it is 3. Realize that as this one too is going up, this one too is going up, right? Yes, so they are directly related. That's all. Now let's look at some mathematical expressions. So from what we said earlier, one pen costs 0.5 cedis. 4 pence will cost 2 cedis. Let the number of pens be n and the cost of pens be c. Now we said that the cost is directly proportional to the number of pens. From the table, from this table, 0.5 corresponds to 1 pen. 2 corresponds to 4 pen. So if you look at the trend very well, you realize that the cost is equal to half a number of pence. numerically. So we can establish a relationship between C and N such that C is equal to what? Half N. Meaning that anytime there's a relationship, something depends on something, there's something that remains constant. So here, half is constant for all. So the cost is always half the number of pence. Always half the number of pence. So the half is constant. So anytime we have a relationship with a proportionality sign, and want to introduce an equal to sign, all we do is we also introduce a constant. So I use the letter K. So y is equal to kx. Here our K is what? Half. Yes. I hope you get it. Okay. Now without wasting my time, let's try some questions to see how well we understand the concept. Okay. If y varies directly as x and y equals 9 when x equals 3, find the value of y when x equals 4. This is a nice question. First of all, we know y is directly proportional to x. That has been established. To get an equation, we have to introduce a constant. So y is equal to what? Kx. But we have to find k to continue with our work. Now from the question, when x equals 3, y equals 9. So let's fix in the values for both y and x. And let's see what we have. We get 9 is equal to k times 3. 9 is equal to k times 3. And that is 9 is equal to 3k. Divide 3 by 3 and you get k is equal to 3. So now you've gotten the relationship. Y is equal to 3x. Now the question is find the value of y when x equals 4. Now put 4 into it and you're done. Simple. Isn't it so simple? Yes. Yes. Let's try this one too. Given that p varies directly as the square root of q and p equals 4 when q equals 2, find the value of q when p equals 1 on 4. You can pause the video to solve it. Let's do the solution together. Okay. So p is directly proportional to q squared from the question. Now, when q equals 2, p equals 4. So now let's put q equals 2 and p equals 4 into this. So we get 4 equals 2 squared times k. Fine. Now let's make k the sub, or let's find k. So k will be equal to 1. Simple. So now you put 1 into the equation you have here. This equation. If k is 1, nothing changes, it just becomes p is equal to what? Q squared. Simple. That's the relationship between p and q. Fine. Now it says when p is 1 on 4, find q. So q is equal to the root of 1 on 4. The root of 1 on 4. And that is equal to 1 on 2. Someone can also say plus or minus. It can be or negative 1 or 2. As simple as that. Good, good, good. Now let's look at inverse variations. But before we look at inverse variations, I would like us to try some few questions. So look at this table. You can pause the video and copy the questions. Send your answer to the comment. You can pause the video and copy the questions. Good. Now let's look at inverse variations. So the correct answers have been provided. If you want to be sure, you can check through using this. Okay. Inverse variations. So inverse variation is a kind of relation that exists between two quantities in which an increase in one quantity An increase in one quantity causes a decrease in the other quantity. So as I'm going up, I'm pulling you down. That's all about inverse variation. These people are inversely related. Also, a decrease in one quantity leads to the increase in another. So that's how the relationship is for inverse variation. For instance, if let's say six girls are sweeping the classroom, six girls in 10 minutes. If we increase the number of girls, let's say the number of girls is represented by X, result in a decrease in the time taken. So we can say the time taken is inversely proportional to the number of girls. So the more the number of girls, the lesser the time. The lesser the time, uh, and and the more the time, the lesser the number of girls. Yes. Simply put, y is inversely related, inversely proportional to x. So that's how we see it. So we can also have a graphical representation here. Yes, yes. So this is it. Now let's look at some mathematical expressions. So this is how I write it. Y is inversely related to x. Y is inversely related to x. So if I want to introduce an equal to sign, all I'll do is I also introduce a constant, so it will get y equals k on x. As simple as that. Now let's look at some questions. So these questions, I'll not solve any of them. I'd like you to solve it on your own and send your answers to the comment field. So you can pause the video to copy the questions. I'll be expecting the answer in the comment field. Thank you. I look forward to watching a subsequent video on joint variation and partial variation.